In computer science, a relational operator is a programming language construct or operator that tests or defines some kind of relation between two entities. These include numerical equality and inequalities. In programming languages that include a distinct Boolean data type in their type system, like Pascal, Ada or Java, these operators usually evaluate to true or false, depending on whether the conditional relationship between the two operands holds or not. In languages such as C, relational operators return the integers 0 or 1, where 0 stands for false and any non-zero value stands for true. An expression created using a relational operator forms what is known as a relational expression or a condition. Relational operators can be seen as special cases of logical predicates. Equality. Usage. Equality is being used in many programming language constructs and data types. It is used to test whether an element already exists in a set, or to access to a value through a key. It is used in switch statements to dispatch the control flow to the correct branch, and during the unification process in logic programming. One of the possible meaning of equality is that, if A equals to B, then we can use either A or B interchangeably in any context without noticing any difference. But this statement does not necessarily hold, particularly when taking into account mutability together with content equality. Sameness versus content equality. Sometimes, particularly in object-oriented programming, the comparison raises questions of data types and inheritance. Equality and identity. It is often necessary to distinguish between two different objects of the same type, e.g., two hands. Two objects being equal but distinct, e.g., two $10 banknotes. Two objects being equal but have different representation, e.g., a $1 bill and a $1 coin. Two different references to the same object, e.g., two nicknames for the same person. In many modern programming languages, objects and data structures are accessed through references. In such languages, there becomes a need to test for two different types of equality. Physical equality, where the two references reference the same object. Interactions with the object through A are indistinguishable from the same interactions through B, and in particular changes to the object through A are reflected through B. Physical identity is not applicable when talking about values instead of objects. Semantic equality, whether the objects referenced by two references, or whether two values, are equivalent in some sense. Structural equality, which may be either shallow or deep. A simple way of achieving this is through representational equality, checking that the values have the same representation. Some other tailor-made equality, preserving the external behavior. For example, 1/2 and 2/4 are considered equal when seen as a rational number. A possible requirement would be that A equals B if and only if all operations on objects A and B will have the same result. In addition to reflexivity, symmetry and transitivity. The first type of equality usually implies the second, but the converse is not necessarily true. For example, two string objects may be distinct objects but contain the same sequence of characters. See identity for more of this issue. Real numbers, including many simple fractions, cannot be represented exactly in floating-point arithmetic, and it may be necessary to test for equality within a given tolerance. Such tolerance, however, can easily break desired properties such as transitivity, whereas reflexivity breaks too. The IEEE floating-point standard requires that nan holds. Other programming elements such as computable functions, may either have no sense of equality, or that equality is itself not computable. For these reasons some languages define an explicit notion of comparable, in the form of a base class, an interface, a trait or a protocol, which is used either by explicit declaration from the programmer's side or implicitly through the structure of the type involved. Comparing values of different types in JavaScript, PHP and a few other dynamically typed languages. The standard equality operator evaluates to true if two values are equal, even if they have different types, making the number 4 compare equal to the text string 4, for instance. A typed equality operator is often available as well, in such languages, returning true only for values with identical or equivalent types. For languages where the number 0 may be interpreted as false, this operator may simplify things such as checking for 0, ordering greater than, and less than. Comparison of non-numeric data is performed according to a sort convention which may be built into the programming language or configurable by the programmer. When it is desired to associate a numeric value with the result of a comparison between two data items, say, A and B, the usual convention is to assign -1 if A less than B, 0 if A equals B and 1 if A greater than B. For example, the C function strcmp performs a three-way comparison and returns -1, 0, or 1 according to this convention, and qsort expects the comparison function to return values according to this convention. In sorting algorithms, the efficiency of comparison code is critical since it is one of the major factors contributing to sorting performance. Comparison of programmer-defined data types may be carried out by custom-written or library functions, or, in some languages, by overloading a comparison operator, that is, assigning a programmer-defined meaning that depends on the data types being compared. Another alternative is using some conventions such as member-wise comparison, logical equivalence, though perhaps not obvious at first, like the Boolean logical operators XOR, and, or, and not. Relational operators can be designed to have logical equivalence, such that they can all be defined in terms of one another. The following four conditional statements all have the same logical equivalency for any given x and y values. This relies on the domain being well ordered. Standard relational operators. The most common numerical relational operators used in programming languages are shown below. Including Fortran 2, 3, IV, 66 and 77. Algol 68. Including Visual Basic, Net, OCaml, SQL, Standard ML, and others. Including Elgol, Simula, Modula2, Delphi, OCaml, Standard ML, Eiffel, APL and others. Including C, C++, C#, Go, Java, JavaScript, Perl, PHP, Python, Ruby, and R. Including Bourne Shell, Bash, Corn Shell, and Windows PowerShell. The symbols less than and greater than are usually used in a shell for redirection, so other symbols need to be used. Without the hyphen, is used in Perl for string comparison. MATLAB, although in other respects using similar syntax as a C, does not use equals as in MATLAB sends the following text as a command line to the operating system. The first form is also used in Smalltalk, with the exception of equality, which is equals. Including Fortran 95, 2003, 2008 and 2015. Other conventions are less common. Common Lisp and Maxima use basic-like operators except for inequality, which is equals in Common Lisp and hash in Maxima. Older Lisps used equal, greater, and lesp, and negated them using not for the remaining operators. Syntax. Relational operators are also used in technical literature instead of words. Relational operators are usually written in infix notation, if supported by the programming language, which means that they appear between their operands. For example, an expression in Python will print the message if the x is less than y, if x less than y. Other programming languages, such as Lisp, use prefix notation, as follows. Operator chaining. In mathematics, it is common practice to chain relational operators, such as in 3 less than x less than y less than 20. The syntax is clear since these relational operators in mathematics are transitive. However, many recent programming languages would see an expression like 3 less than x less than y as consisting of 2 left associative operators, interpreting it as something like less than y. If we say that x equals 4, we then get less than y, and evaluation will give true less than y, which generally does not make sense. However, it does compile in C, C++, and some other languages, yielding surprising results. It is possible to give the expression x less than y less than z its familiar mathematical meaning, and some programming languages such as Python and Perl 6 do that. Others, such as C# and Java, do not, partly because it would break away from the way most other infix operators work in C-like languages. The deprogramming language do not do that since it maintains some compatibility with C, and allowing C expressions but with subtly different semantics would add more confusion than convenience. Some languages, like Common Lisp, use multiple argument predicates for this. In Lisp is true when x is between 1 and 10. Confusion with assignment operators. Early Fortran was bounded by heavily restricted character sets where equals was the only relational operator available. There were no less than or greater than. This forced the designers to define symbols such as GT, LT, G, EQ, etc., and subsequently made it tempting to use the remaining equals character for copying, despite the obvious incoherence with mathematical usage. International Algebraic Language and ALGOL therefore introduced equals for assignment, leaving the standard equals available for equality, a convention followed by CPL, ALGOL W, BCPL, Simula, ALGOL 68, SETL, Pascal, Smalltalk, Modular 2, Ada, Standard ML, OCAML, Eiffel, Delphi, Oberon, Dylan, VHDL, and several other languages. B and C. This uniform de facto standard among most programming languages was eventually changed, indirectly, by a minimalistic compiled language called B. It was a language with the sole intended application as a vehicle for a first port of Unix, but it also evolved into the very influential C language. B started off as a syntactically changed variant of the system's programming language BCPL, a simplified version of CPL. In what has been described as a stripped-down process, the and or operators of BCPL were replaced with and. In the same process, the ALGOL style equals of BCPL was replaced by equals in B. The reason for all this being unknown, as variable updates had no special syntax in B and were allowed in expressions. This non-standard meaning of the equal sign meant that the traditional semantics of the equal sign now had to be associated with another symbol. Ken Thompson used the ad hoc equals combination for this. As a small type system was later introduced, B then became C. The popularity of this language along with its association with Unix led to Java, C#, and many other languages following suit. Syntactically, despite this unnecessary conflict with the mathematical meaning of the equal sign, languages' assignments in C have a value, and since any non-zero scalar value is interpreted as true in conditional expressions, the code if is legal, but has a very different meaning from if. The former code fragment means assign y to x, and if the new value of x is not 0, executes the following statement. The latter fragment means if and only if x is equal to y, executes the following statement. Int x equals 1, int y equals 2, if *, this code will always execute if y is anything but 0 *, print, though Java and C# have the same operators as a C. This mistake usually causes a compile error in these languages instead, because the if condition must be of type Boolean, and there is no implicit way to convert from other types into Booleans. So unless the variable that is assigned to has type Boolean, there will be a compile error. In ALGOL-like languages such as Pascal, Delphi and Ada, as well as in Python and many functional languages, among others, Assignment operators cannot appear in an expression, thus precluding this class of error. Some compilers, such as GCC, will provide a warning when compiling code that contains an assignment operator inside an if statement, though there are some legitimate uses of an assignment inside an if condition. In those cases, the programmer would need to explicitly wrap the assignment in an extra pair of parentheses to avoid the warning. Similarly, some languages, such as BASIC, use just the equals symbol for both assignment and equality, as they are syntactically separate. Some programmers get in the habit of writing comparisons against a constant in the reverse of the usual order. If ** mistaken use of equals versus equals would be a compile time error ** if the programmer accidentally uses equals. The resulting code is invalid because 2 is not a variable. The compiler will generate an error message, upon which the proper operator can be substituted. This coding style is known as left-hand comparison, or Yoda conditions. The following table lists the different mechanisms to test for these two types of equality in various languages. Patent application. On May 14, 2003, U.S. application 20,040,230,959 is not operator was filed for the ISNOT operator by employees of Microsoft. This patent was granted on November 18, 2004.